Now that we have an intro to Ksp ice charts and solving for X from a Ksp ice chart, which really represents your molar solubility, meaning the quantity of the solid that is dissolving, we're now going to use ice charts to now calculate Ksp values, so the second main type of Ksp problem. So let's turn to problem number 4 from your Ksp note sheet. Okay, number 4, copper 1 bromide has a molar solubility of 2.0 times 10 to the negative 4 molar at 25 degrees Celsius. They would like for us to calculate Ksp for the copper 1 bromide. So copper 1 bromide has a formula CuBr. It has a molar solubility, so that means X is 2.0 times 10 to the negative 4 molar. So start by writing out your equation. Solid copper 1 bromide breaks up into copper 1 plus ion and bromide 1 minus aqueous ion. Some amount of copper bromide dissolves. The initial concentrations of the ions 0. This is in pure water. Okay, so I know that this is going to be my ice chart for Ksp problems. We really don't care about the reactant because it is a solid, so if you want to omit that part, you may. And in the very end, at equilibrium, copper ion is X, bromide ion is also X. I should be able to write my Ksp expression using the balance equation. Ksp will be equal to copper 1 plus times bromide 1 minus. And remember, Ksps never have denominators. Now we're going to plug in our values. Ksp is equal to X times X. In other words, Ksp equals X squared, because X represents the equilibrium concentration of the copper and the bromide ion. So the problem wants us to solve for the Ksp value. Well, we know Ksp equals X squared, and they also told us what X was. X is the molar solubility, which is 2.0 times 10 to the negative 4 molar. So all we're going to do is plug in 2 times 10 to the negative 4 quantity squared, and we'll have the Ksp value. Practice your mental math here. 2 squared is 4. And then 10 to the negative 4 you multiply. And you get 10 to the negative 8. So if we're rounding for sig figs, there's 2 sig figs in the problem. So the final answer is 4.0 times 10 to the negative 8. And that is the Ksp value for copper 1 bromide. Remember, Ksps do not have units. Right, now I want you to try number 5 on your own. Use the last problem as a guide to help you with number 5. Please hit pause. Come back when you're done with 5. In number 5, we have bismuth sulfide has a molar solubility of 1.0 times 10 to the negative 15th molar. So they gave me the value of X, and they would like for us to calculate Ksp. So I have my ice chart for bismuth sulfide, and at equilibrium, bismuth ion is 2X, and sulfide is 3X. Watch out for those coefficients. There's 2 bismuths, and there are 3 sulfides. Please get into the habit of writing out the Ksp expression. So Ksp is equal to bismuth 3 plus ion squared times the concentration of sulfide 2 negative ion cubed, using those coefficients as the exponents. So Ksp in terms of X, bismuth is 2X, that's squared. Sulfide is 3X, and that is cubed. So simplify a bit, get 4X squared times 27X cubed. And then keep on simplifying. 4 times 27 is 108. And then x squared times x to the cubed, that is x to the 5th power. So Ksp equals 108x to the 5th. And they gave us x, which is molar solubility. So you're going to plug in 1.0 times 10 to the negative 15 for x. To the 5th power. So you solve for Ksp and you get 1.1 times 10 to the negative 73rd power. That is the Ksp value of bismuth sulfide. And just take a look at that value of Ksp, negative 73. Very, 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 very insoluble practically, but just slightly soluble. This is heavily reactant favored. Bismuth sulfide essentially does not dissolve, but we know that insoluble really means slightly soluble, so just a tiny bit of this is going to dissolve.